Okay, that is great. Guys, hang in there. We have a very interesting session coming up. We have Sam Ong, Managing Director, TRD Singapore, on the anti-drone technologies, a player who has been very, very visible on the Asian scene. They worked with the defense forces for Malaysia, Thailand, Myanmar, besides others in Asia, and they also are working, I believe, with NATO and the US Marines. Over to you, Sam.
Okay.
And while you're getting ready, let me introduce Dr. Arshad Jamal, Chief Scientist, DRDO, who will also be speaking right after you, Sam.
Good afternoon, gentlemen. First of all, please allow me to share my screen.
Housekeeping, yeah. Please allow him to share his screen. You've been a good man, Sam.
Okay, let's try again. Huh?
Yeah.
I can't share my screen. Any reason for that?
Tech team, back up. What's up? Neetu, are you blocking your screen? Switch off your screens, no? Your session screens.
I'll ask Shankar, he'll be doing so.
Yep, thank you. Sam, you can start talking while your screen is coming up. Sam, are you there? Hello? Okay, while Sam sorts out his issues, can we have Dr. Arshad Jamal? Dr. Jamal, can you please tell us the exciting news that DRDO is coming up with indigenous anti-drone systems? That's what I've overheard in some conversations. Tell us what's happening. Dr. Jamal. Dr. Jamal, are you there?
Can you hear me?
Yes, sir.
Yeah, good afternoon, sir. Yeah, good afternoon, sir.
Good afternoon, sir.
So I was supposed to talk about the drone technologies that we have been working. So some of the work that we have done, especially on autonomy and cognition part, how these drones, what are the different ways in which these can be operated, what are the new technologies that have been coming up. Regarding the anti-drone system which DRDO has developed, I think whatever is there in the open forum, that only we all know. Nothing else I can tell on this forum. So I think
Before Sam comes on, he's trying to get his screen up. But what we'll do is we'll allow Sam to speak the moment his screen comes up. And in the meanwhile, let me ask you a question. Yeah. How have you done any work on anti-drones at the moment in your part of DRDO?
Our part, we are focused more on the drones or unmanned systems, autonomous unmanned systems, both ground and air.
What have you done for traffic collision avoidance in drones?
Yeah, so there are various ways in which we have done. So depending upon the operational need, for example, there could be optical sensor-based collision avoidance, or there can be lidar-based collision avoidance. So these are the two main sensors that we have seen. For the ground-based system, we have used other sensors like millimeter wave radar and the heavyweight sensor. But for the drone, because the SWI is the biggest constraint there, so the two sensors that we have used is the optical and the lidar-based sensors.
I think that's Sam's presentation.
Yeah, I think yes.
Sammy, is that you?
Mr. Sam, your mic is muted.
Let me try to get it up. Okay.
Now your mic is on. Your screen came on.
Yes.
Then it went off again.
Okay. Let me see.
Yeah, it's there. Fire away.
Okay, you can see my screen now?
Yes, if you can enlarge it, it'd be nicer. Otherwise, fine.
I'm trying. Okay, got it.
Yes, perfect. Go ahead.
You got everything?
Yes, sir. Yes, sir.
Really
Go
good.
ahead.
Thank you very much. Again, thanks for inviting me to join the forums. What I'm going to do is I'm going to share a bit about the present and emerging drone track. And one important idea is actually about the red teaming and blue teaming. And I'm going to use Changi Airport as a case study to put some ideas to see how do it applies and what are the gaps. Then the last part I'm talking about will be R&D against the evolving threat.
So therefore, this is a presentation case study of Changi Airport of Singapore, right?
Yes. I'm going to use it to study, for example, when we talk about detection, talk about FICCI, talk about jamming, how can put together.
Okay, sir. Go ahead.
First question is there's no silver bullet, but we can do something about it. Well, now the limelight is on US. Even a simple drone that hit the World Trade Center is a wake-up call.
Mm-hmm.
Yeah. Then this myself, 25 years military, and I'm happy and thankful of the opportunity on anti-drone. We started early. These are the country that we have user. 7 Airbase, Changi Airport, Singapore, and even some European customer. Okay, I think green, yellow, red is what we talk about. Many systems out there. Detection and also for defeat. Okay, the first question is how do we understand the drones and so that we can cater the regulations, the technology, and the solutions. Today, most of drone we talk about ISM band 2.4, 5.8. There are some DIY drone, there are 4G drone coming, very cheap commercial Chinese drone, but there are also military UAV grades for attack mission. Coming soon, commercial drone get cheaper.
Question.
Easy pay.
Question. Sorry to interrupt. When you said military drones, do they use a different frequency or it's?
Yes, indeed. If I was skip the last slide, we need to differentiate between military UAS and commercial drone.
Okay.
Yeah, because sometimes when we try to address drone, you end up looking at military UAS, and that will be the air defense and air force issue.
Mm-hmm.
But the line is thin because some of the technology from the military UAS are now going to the commercial because of affordability. For example, inertial navigation system. If the commercial drone is going to use the inertial navigation system, which only common in the military grade UAV, then you can't even jam the GPS. Yep. So what's coming is really commercial drone get cheaper. They can put easy payload, non-ISM band, swarming, and even they can hop from remote control to remote control. One guy fly, another guy took over. Another area to take note is really the VTOL UAV, vertical takeoff. Now drone, most of them are.
Sammy, hold on. So what you're saying is one guy takes off the drone and somebody else 5 kilometers away takes over the drone and therefore increases the range of the drone. Is that what you're saying?
That's exactly. Today, DJI drone, you can do that already. FPV.
Oh, okay.
Yeah,
that's interesting.
So the remote control change, you go to a longer range. So these are things that are emerging. And of course, VTOL is something to look out because the signature will be very different compared to a normal drones. And VTOL can carry more payloads. They can fly take off vertically, fly long distance. And of course, the future, a lot more drone will come. And drone will have anti-jamming, visual reckonings. So we need to prepare for it. So the purpose of this slide is to put together today, emerging, and the future drone that we have to address. Now, one very important idea is about red teaming. How do you test your system is working? How do you test your digital sky counter drone system working? How do you test your airport are really good enough? So in Singapore, in fact, most countries, I encourage them, you must have red team to attack the blue team. From war game, from table discussion, from actual trial. So the red team should be considered of drone expert understanding of anti-drone. They should conduct anti-drone equipment evaluation and validation. And they should spend time, do surprise attack, and see how the airbase airport report. And one important point, do not live with Mickey Mouse anti-drone equipment. Testing are very important. So with this, you need an anti-drone room at R&D. But before that, I talk something about, this is what TRD presented to US. US have an office called US Joint Counter Drone Office. It used to be joint counter ID, now become joint counter drones. So they look at the whole spectrums of homeland security and application. At TRDN, what we have also system to use for soccer match, police, Air Force, in helicopter, Air Force, Airbase, military op. So essentially, the counter drones must be customizable, flexible, and adaptable. If we remember last sessions, General PJ Peru talked about homeland and border, a huge frontier to defense. Terrorists and attackers usually like to attack airport, air base, navy base, oil and gas, national landmark. Why? These are very easy targets. It's always there and big. As long as they can infiltrate to an airport, land on runway, they win, even without explosive. So this should be the fixed infra that we should look at, and really, what can we do? So I'm going to use Changi Airport as a case study. So first, of course, military or planning. Set the objective, establish the priority area to defense, terrain study, likely approach of the drone. What are your existing security system? Certain CCTV camera may be linked together so you can find the operators. What are the regulations? Airport are very, very strict. Solution, demo, operation setup, rule engagement, red team test. Airport, another challenge of all infrastructure, you need to be operational 24/7. So how do you get after sales support? And when new drone come, how do you upgrade your system and regular red team tests? To start with the concept, for last few years, we encounter many suggestions. So one way is to put a giant circle, giant bubble, 10 to 15 kilometer cover the airport, cover everything. Is this a practical way? Do you see drone fly out from center? Maybe a sectors, 4-sector approach to cover the funnel, a 3 to 5 kilometer requirement, that could be more realistic in terms of requirements. So if you take the concept of multiple sector, basically to protect the the aircraft approach and departure funnels. These are places the airplane are coming in, take off. If a drone knock it, big questions. So typically, both the gentlemen mentioned, you need radar, you need RF, acoustic are really less effective. You need camera, EOIR, so that you can see different signature. Jammer will be a basic, but jammer challenge will be clearing all the frequency interference. Hard queues, yes, it will be something you need, but which one exactly? And which one can be implemented in the sensitive area like airport? Well, the other part is how you put all these things together, how you do auto detect and jamming, and all the fixed site system, eventually you need to complement with a man-portable vehicle solution. Okay, so over here you can see a red area. You can define red areas, and this will be an area that drone come in, detect, auto scan, auto jam. And eventually all these counter drone systems you link to the unmanned traffic management. So as a country, everything is linked up. So then we talk about compatibility, how the C2 information can be sent over to a central location. This is what we have implemented. I hope the video can see. Okay, this is the airbase. Without mentioning country, we have installed radar, camera, jammer, everything together.
Full system test.
So full system test.
Flying. Okay, this is a full system test. Drone flight.
If you see, this is the runway. There's an area of interest. This is a radar camera. So when a test drone go into the areas, you'll be auto switch of the camera and jamming.
Area of interest. Detection by Robin radar. Okay, we set
radar detected.
Jammer and camera.
Jammer was facing away. Okay. The yellow one is a jammer.
Now the
drone go entering into the area. You see the jammer will turn.
Okay.
Camera will also through to the targets.
Okay.
Automatically.
And rotate and through to
Does
the
it still have link?
Okay. And jammer also activated.
Jammer activated.
Okay. You see the blink. You see the blink.
Oh, we got jam.
Okay.
We got jam. Very good.
It's good.
Congratulations.
Okay, I will turn off the camera now.
This testing was conducted remotely in Singapore because of COVID. So this is in another country of
Okay,
ASEAN.
so again, we radar, camera, jammer all deployed here. We fly the drones. Drone go into the area of interest. Okay, detected by radar, camera turn, jammer turned and jammer activated, and the drones was disrupted, neutralized.
Okay, that's a typical video to show, and this slide is very a complicated slide, but these are typical the system you need from 3D radar, RF, ADS-B, so you know the aircraft, you don't get false alarm, EOIR, and the defeat will be from jammer to net, and of course take control, and future to come with HQ. All these need to be pulled together. Data fusion will be something important, and all information should be able to link to higher HQ, UTM, and augmented by man-portable or vehicle system. Why man-portable or man-pack system? This is typically how it look like if you deploy on fixed site.
Sam, I have a question.
Mm.
You showed us this detection of drone coming into the airport. So I'm assuming, just assume for a minute, that the airport or anything is critical infrastructure. Did you have only one detection device there, or do you have multiples to create a dome? Because the aircraft actually entered the perimeter. Now, what Rajan Luthra was talking about is geofencing to make sure nothing enters. So that's the challenge.
Okay, first question about geofencing. Geofencing only work on certain drone. For example, DJI geofencing, in the areas DJI drone cannot take off. But if you are DIY drone, you are Evo drone, there's do not have a geofencing by the manufacturers. So geofencing will not work. So typically you see this one is, then we are talking about 4 sets of counter drone equipment to cover
on the 4 corners, like for example.
Correct,
right?
correct. Instead of having a big bubbles, 10 kilometers, and you get out a lot of blind spot, and typically drone cannot take off somewhere in the middle of the airport.
Mm-hmm.
Yeah, so this is one concept. Yeah, this one will affect user writing requirement. You ask for 10 kilometers or you ask 3 to 5 kilometers.
So that's interesting, because a lot of people think that the longer range is better for detection. So what you're saying is, it's rather than have a longer range, you have a shorter range, but you have multiple pieces to give you sort of a safety dome.
Yes, they want longer range because aircraft approaching a certain height. So in concept, multiple sector is better. If the budget afford, instead of 3 to 5, you can have from multiple sector go out, extend to 10 kilometers. So you actually get a 10 kilometer, for example, a 10 kilometer radar, you get a range out. So you have to have 4 radar. Instead of putting 1 radar in the middle of runway, you lost 2 kilometers on each side because no drone is going to appear from there.
Can you explain this? I'm not understood. You're saying
Okay.
having a long range radar is not really going to help as much as having 4 short range
Correct.
radars.
Because if you have only 1 long range radar, you have to put in the middle of the airport. So you lose 2 kilometers on each side for the runway because no drone is going to come out from there.
Yeah.
So technically, the 10 kilometer radar, you wasted half of the range. So the correct deployment should be at the edge of the funnel, looking out.
And that creates a sort of a dome.
Yes, this create a dome. So this is concept, and this one you will have less blind spot because if you only have one system put in the middle of airport, you're going to have a lot of blind spot being blocked.
But tell me, when you have these systems, they're auto detection, 360 degrees, constantly happening.
Yes.
How much? So you'll have to synchronize it in such a manner that at any given point in time, there are no blind spots. For example, if a drone is flying in at, say, 50 kilometers an hour, and he's been launched, say, 2 kilometers away or 4 kilometers away from the periphery, you should be able to detect him, right?
Correct. Correct. The detection must have certain response time.
What is that typically? What is it?
Typically, they'll spec it at 3 to 5 kilometers. So that the decision maker, because for airport, typically they also cannot do auto jamming. What if you jam your own drone or affect the aircraft? So typically the decision time from confirmation of target, they can take 30 seconds to 1 minute because they always want the camera to confirm the targets, whether the drone carry a bomb or don't carry a bomb. Then after that, the decision maker at the off center will decide, okay, turn on jammer, jam all the frequency, or jam without the GPS frequency. So typically decision time, I'll say even up to 30 seconds or 45 seconds. So 3 to 5 kilometers, if a drone flying at 10 to 20 meters a second, you have enough time to take the actions.
Okay, that's useful. Thanks. Continue.
Okay, this is the full system. Typically, how you look like deploy at the funnels. Okay, and I want to highlight something about radar. Yeah, there are so many radar in the market. What we do is we test all of them. Then you'll find that every radar have their own characteristic, own range, different price. So the important point here is you must really evaluate every radar system on site and compare with a few shootout. And of course, make the system integrator responsible for the performance. Just now, apart from fixed site, apart from the fixed system, sometimes you also need mobile system to go outside the airport, go patrolling, so that they can detect the drone outside. And one more thing important, finding the operators. If the drone comes to the airport, you shoot it down. That's not an end story. The guy will know that direction, you'll be shot down. Tomorrow, he'll come back again, fly another direction. How do you then mitigate this problem? So the important part is how to catch the operators. So to catch the operators, you need mobile system that go out. Anyway, this is one of our projects that we are building just to share. Today, technology system is able to put everything on the vehicles. Radar, RF, EO, 6-band jammer, C2, generator, aircon as well. Yep.
Yeah, this is what Mr. Luthra was talking about, that you need to have a mobile system in areas where there's a blind spot. Yeah.
Correct.
Okay.
And from time to time, maybe you send the one like this police car. This guy is police car, go out, collect the information. Whether they get approved or not approved, so you can compile data.
So this is very useful for VIP movement, right?
Yes.
So just to understand the range, you mentioned two things in the initial remarks, that you said in open areas you can get a long range detection. How do you battle city structure where you have buildings?
Yep. So for example, the first the 2018, this vehicle, it can go about 5 to 8 kilometers in the open area like this. If you go into the busy areas, typically you get about 1 kilometer. Yep. So
is that enough? Is that enough to jam?
Okay, it's enough for jamming. Jamming will go further than the detection system usually. Yeah, it is the RF detections, and in area like this, it may be very difficult to deploy radar. Radar usually gives false alarm, but of course you can afford it. You put everything like these vehicles, radar, RF, camera, everything together.
Sam, hold on. There's a challenge. You see, the challenge is there's a drone which is flying in a city, which you've detected is a rogue drone. What does the system do? Does it send it home, or does it make it crash on someone's head?
Okay, good question. So first of all, this deploy system must be within the protection of VIP, for example, VIP event. They will have ROE. Typically, the ROE will jam the drone, try to disrupt it. First thing is they must not fly in. You must stop the drone. So after stop the drone, they have an option to send the drone home if you don't disrupt the GPS. Usually the drone default setup will be returned home or land, and they does not crash. When a drone is jammed, most of the drone does not crash. You land nicely. But if you use a hard kill, flying a drone with a net or laser, the drone is going to drop, no matter what.
Can you repeat this last part? This is very important.
If you use jammer, the drone disrupted, they'll land or go home. They'll land slowly. If you use a hard kill solution, for example, you fly a drone out with another to catch it, or use laser, or use bullets, the drone is going to drop.
Yeah, it's on someone's head in a city.
Yeah, drop on someone's head. So that's why the concept of rural engagement becomes very important. So apart from vehicles,
just one sec, Rajan, since you're there still, the rules of engagement is something you guys need to look at when you look at anti-drones and drones. Just thought I'll flag that. Yeah, please go ahead.
Yeah. So that one if you go back to the planning part, the rural engagement is something very important. Very important. And also the decision cycles. Yeah. Okay, so just now we talked about full system, you need vehicles and man-portable system. I think some gentlemen talk about man-portable system. So yes, they are man-portable detection system. Personally, from experience, I find only this system can locate the operators. Why? Because the operator must be hiding somewhere to fly, either on the building or on some concealed area with his remote control coming out. So the RF and detection with a direction pointing device, you probably have a chance to point out and get the operator's information. Of course, some blind spot cannot be covered at fixed site. Then you have to augment it with a jammer. Yeah, man portals have to cover the blind spot. So typically, what airport do is they have level of emergency. When they say green, peacetime, no drone, then they operate a green mode, just the basic system. When they're yellow means they're spotting a drone, they'll deploy the man-portable team. Red, everyone will be on alert, means drone intrusion. So also a different level of...
Sammy, hold on. What you're saying is that in Changi, you have fixed systems and you have portable systems also.
That's correct.
So what is the protocol of usage?
Okay, first of all, is whether high alert or low alert. If high alert, some suspected area, they will actually send the man-portable team to the suspected area. Yeah, and sometimes also when your system is on maintenance for fixed site, then they'll deploy temporary the man-portable systems. Because the fixed site, sometimes you maintain an upgrade, it could be half a day, it could be 1 day.
Yeah, okay. Maintenance is an important point, yes.
Yeah, so make sure there's no gap 24/7 because the plane need to fly all the time. Yeah. The important is really finding the operators, which is tough. So coming back to this, what are the challenges and gaps? First thing is money. Well, a lot of people think Singapore is to pay this amount of money, again, $2,000 drone. So I can tell for this anti-drone system, they probably spend close to 10 million. Yeah. But
yeah, it's asymmetrical, I agree. But you want the 10 million, you saved aircrafts worth 200 million each. So it's asymmetrical.
That's correct, but only after a wake-up call. After July 2019, the drone intrusion, then everything speed up. Then the other part about detection, need to calibrate really false alarm because it's going to have a lot of transmission, a lot of bird, a lot of planes. So how do you calibrate the system? That will be over time to do it. Then the defeat, the regulation. Can you turn on a jammer? Will it affect other system? Collateral damage. Even drone land, it can be land on the roads. Yeah. So all the ROE, rural engagement, all the SOP need to come.
Question.
Yeah.
Sammy, question. When these devices are the auto detecting 360 degrees round the clock, does it interfere with the Wi-Fi systems and the radio communication and the nav systems of the aircraft coming in and taking off?
Okay. The detection itself does not affect because, for example, RF. I talk about RF. RF is passive. That's why a lot of places RF is welcome because RF is passive, unlike radar. Yeah, but RF alone is not enough because what if the drone do not transmit? What if out of the frequency? So radar is needed. So the radar need to check the radar frequency that does not interfere with the aircraft or air traffic control frequency. That's why just now I show you for radar. In fact, for airport, airbase, all this, you need to do a full spectrum analysis. Who is using what can be used for radar, and later on when the jammer turn on, who has yeah.
Fair enough. Please continue.
So number 4 will be data fusion. This is something that everyone try to work. Very first important is you must have the correct sensor. After that, then we talk about data fusion. Put it together so the operator can identify threat faster. Yeah. Training is the tough thing because to train operator, operate a full suite of system, not easy. And of course, we talk about last point is maintenance upgrades. So these are challenges that need to continue to be addressed. Okay, this thing, what I'm going to talk on is about R&D. R&D, these are the spectrum of the areas. Okay, I got this. Totally agree, soft kill or hard kill, there's no foolproof solution to counter drone. Everybody need R&D. What's important R&D, also the optex interactions. Never have a closed door building of technology without understanding the operational need. Yeah, so this main point, I'm happy to share what TRD have planned our roadmap. So these are the drone track that we identified. So based on drone track, these are the R&D that we have done. The first block is what we have completed. And the second block, I would say somewhat important thing is like RF detection and decoding. Can you decode the signal so that you find the operator's locations real time and catch it? Or after you catch a drone, can you do forensic to go back, oh, this drone belongs to who? So this is the near term what we are doing. Also the effective data fusion using artificial intelligence machine learning. And looking forward, 2-3 years time, nano swarming drone flying with INS using visual recognition, even drone may have anti-jamming. Then how do you handle it? So the hard kill system must still come in to find a correct one. And eventually, all these anti-drone, counter-drone system must integrate with the UTM, national level. So you have a national level, putting all the bubble together. And of course, the aim is counter-drone must able to take care of mil-grade drone. Because eventually, the commercial guy also can get this military technology. So this is a 3-year R&D plans that we're looking to. And of course, we're finding partner to explore on this.
Sammy, I have a question for you. We, in the initial stages, talked about mil standards, mil frequencies. For our friends from the defense forces, what do you think should be the kind of challenges they would be facing when they pick up anti-drone equipment, and they should be taking up and it has both mil and civilian standards? Because mil is okay, one part of it, but you can also get a threat from a civilian drone.
Yes. So the question answer will be two. First is we need to understand what kind of drone, commercial, military. So you want to take care of both. Then the detection, what's being able to detect. So radar will detect anything move, but give a lot of false alarm. Then the RF, you now need to cover wider frequency, much wider, and stay with it. Military can use different frequency they need, and they can even fly drone with INS without communication. So I would say depend on the threat levels. Typically, commercial drone is more, but the system need to be eventually upgraded and ready to take care of military.
No, I agree. See, Sam, what I'm seeing is that it doesn't matter what frequency it is, mil or otherwise. This line disappears into, diffuses, because the guy who's using the drone may use any frequency to attack some sensitive facility. It could be civil or military. That's what I'm looking at.
That's correct, but on the practical side, it's also not easy to get a transponder or a frequency link system that outside the frequency, because they need to build, and potentially they can also be interfered by other systems.
Such as?
For example, if you use the a certain frequency like 5.1, is the radar is using, so when the drone fly, they get interrupted. Yeah.
So what gets interrupted, the drone or the radar?
A drone, because radar will be much higher power.
Correct.
Yeah. So these are things, but of course, if in terms of terrorists, they can build this anytime. Yep.
Yeah.
The other challenge to come actually will be the 4G, 5G drone.
Yeah, tell us about that. You raised that issue earlier.
Yes, because when 4G and 5G drone they fly, basically they put a SIM card, so their RF signature is like a phone. Of course, radar can pick it up, but RF is not easy. Yeah.
All right. So if you have that situation, it's possible it'll happen very soon in some part of the world. The question then is, how do you send the guy home in that frequency?
Correct. So
you're sending the entire telecom system home, is it?
Yeah. So you have to do, unfortunately, if you talk about jamming, you have to use 3G, 4G, 5G jammer to jam the signal. So this has to be selective because if you point to the base station, you could affect the base station. But usually this we have tested. You just need to jam directional jamming. 30 seconds, you disrupt the drone and the drone will land.
And the telecom signals come back after 30 seconds. Is that what you say?
When you point to the drone, normally you will not disrupt the base station. So the rest of people will not get affected.
No, what happens if unfortunately you also jam the base station for 30 seconds?
Okay, usually there'll be a few base stations to support telco. But really, unfortunately, you point to the base station, you may disrupt it. But usually a base station signal is very strong. So the downlink is very hard to jam, but the uplink from the drone to the base station is the one that you are cutting off. So potentially any phone user near the drone can be cut off, but the base station usually should not be affected. That's why it's important before you use the jammer, is study the terrain. Where are the base stations? So if the drone flies to base station, you don't jam it. When away from base station, then you jam it. That will be the SOP and rule of engagement.
Okay. Well, that's interesting. So you got a new challenge of spectrums coming up. Rajan, you want to react to this?
Sorry?
You want to react to this? Rajan, I'm asking Rajan. Rajan, are you there?
Sorry, I was on mute. So
yeah, go ahead.
What I was saying was that everything that Sam just mentioned are all, happening now. So 4G drones are available today and are likely to be present in India as well. I think the main issue here is about not once again so 2 points I would like to maybe add. Number one, the concept of operations and the rules of engagement will depend from location to location, asset to asset, and who is the operator of the asset. Number two, in terms of the technology, I think the technology problem can be solved by designing the system well. But there are still some regulatory aspects that will need to be addressed in parallel because there are multiple stakeholders involved.
Okay. Yes, Sami.
Yes.
It's all yours to finish.
Okay, totally agree. That's why technology is key, but we need to overcome all the challenges. Knowledge, experience requirement, regulatory and rule engagement, the choice of solution training, fast cycle of drone technology. Usually drone technology move much faster than anti-drone or counter-drone, and of course the cost. So some of solution really need a lot of hands-on lesson, red team, mission-driven, innovative, regulatory exemptions, so that your own red team, your own defense system will not be handcuffed. Practical and proven solution. Nothing will be perfect. And fast cycle of procurement, like shortcut some of the process because drone move very fast. Yep. So my last slide, there's no silver bullet. We need to fly faster and do better than terrorists could, and continue to learn this journey because drone is going here to stay for a long time. So we have to prepare for enduring better. Again, thank you for the opportunity. I look forward to evaluate to the India effort in countering drone and hope to visit the country soon.
Thank you, Sami. We're going to have some questions. There were some issues raised. Guys, I'm having a technology problem. Those of you who sent those messages, can you raise your hands and ask your questions, please?
Yeah, Harry, this is Rajiv Narang.
Yeah.
Sam, just want to understand this counter drone jammers. Are we going to operate? They are going to be integrated with detection jammers and operate autonomously, or it will be a man-made? What do you see trend because of very little time available to the defender? Thank you.
Yes. Exactly. That's why it depends what you are defending. If you are defending a VVIP speech, typically in no time. So what you do is even during the critical hours, you turn on a jammer. Just for sharing, if a VIP aircraft is coming in during landing, sometimes we just turn on the jammer. So the drone have no chance. So for a fixed site protection, you must have a jammer like this one integrated into your command and control system. Then you'll be ROE to set portable system. Man-portable system is more for ad hoc event and complementary. So technically, you need both.
Thank you.
Yeah.
Any other questions, please?
Hi, Sam. This is Rashmi.
Hi,
Sam, I wanted to know more on the forensics part of it. So after the interdiction, can you throw some more light on the forensics section?
Yes, forensic is a tough part because when you dissect the drone, what can you get out from the drones, the signal? So there are three parts of it. First of all is RF. When you detect the signal, you must do the recording of the drone raw signal. What was the protocol used? And for example, if you can decode the signal like DIY, you can get exactly the location, you get exactly the position and information. So one part is the real time when you are detecting it, how much information you record. Then after that, when the drone landed, when you take the drones, whether you can trace back the history, can you go to the firmware and look at the ID, and then potentially even the drone is, if the drone is registered, it's easy. You look at the sticker, you look at ID, you can trace back who drone is it. If the drone not registered, if you can get the ID, there's still potential chance you can trace back to the OEM and where he buy this drone. Yeah. So I in summary, forensic are three parts: collect the informations. When you dissect the thing, how can you extract more? Then from there you trace it back to the operators.
Rashmi, does that answer your question?
Yeah. Thanks.
Rashmi, where are you from? We don't know where you're from.
So I'm from Reliance, Harry.
Okay, great. Excellent. Any other questions, guys? Mohan, go ahead.
Hi, hello everyone. I'm Mohan from Honeywell. I have a question for Sam. The technology that you're using to jam, are you using it to jam only GNSS frequencies, or are you jamming communication frequencies also?
Good question. We started with 3-band, 6-band, 8-band. Now we have a jammer that can do 400 megahertz to 6 gig. So starting is 2.4, 5.8 GPS L1. Then the 6-band add on to 433, 915, and GNS L2. These are typically the ISM band. Now we even go to 5.1, and to tackle a 4G drone, then you need to have wide spectrum. So I must say, from 3-band to a wide spectrum jammer we have.
Sure. A follow-on question: with the inertial navigation system and alternative navigation like vision, radar-based navigation, very soon these jammers would become irrelevant because you're not going to depend on GVS or any other GNSS systems for navigation. So how do you counter such a situation?
That is correct. That's why a layered defense is needed. First, you try to jam. If the drone continue to come in, then you need to have a HARQ solution. The HARQ solution could be a drone with a net, laser, HPM, EMP, or bullet, or the last round in the Venezuela case, President, they use an umbrella. So we are investing and look at the HARQ. The challenge today is laser. Apart from expensive safety, it only can cover very short distance and provide the drone is hovering. Drone net is hard to catch a net, so HARQ will be needed.
Okay.
Thank you.
All right, guys, thank you so much. Now over to Dr. Arshad Jamal. Dr. Jamal from the DRDO. Arshad sir, please tell us what your thoughts are since you missed this part of the session. You had a mixture of drones, drone policy, and anti-drones. Shoot ahead. Yeah. Go ahead.
So I'll just share my screen.
Yes, please.
Is it visible?
Yeah, it is.
Okay. So good afternoon. At the outset, let me first thank the organizers here. So I'll be focusing more from the developer point of view, that what are the things which normally goes into a drone. Just to begin with few of the general points which I just want to skip. So I will just talk about point number 5 here, which others have also spoken, asymmetry. We are saying that the low cost drone, and then we are trying to create a solution that is very high cost, but then at some point it is justified because the thing which is being defended may be of high cost. The other point which I want to bring in here is the multipolarity, which I think nobody has talked about. So what I mean, it is important to understand that the potential of the drone platform, it has basically compelled most of the states to identify as a aspirational goal. So that means we have two aspects here. One, that everybody want to create a drone as a weapon system, and then it basically creates an opportunity for a counter drone system. So we have this multipolarity, and I think as a nation we should also look into both the aspects, creating these platform as a smart weapon system, and also creating a counter of those drone technologies. So that we have to, apart from the asymmetry, we also need to remember the multipolarity aspect of the technology. So now, while working on these technologies in our lab, what we have come across in last few years, maybe 2 to 5 years, I would say, starting from say teleoperation mode of thing, where there is a continuous RF link, and so that means there is an opportunity that the RF signature is always available, which can be then tapped in, and this drone can be identified. The range of operation will be mostly visual line of sight. Then we went to semi-autonomous mode, where there is an autopilot system, and then somebody can specify waypoint like being shown here. So somebody can give a set of waypoint, say point number 1 is starting from this place, and it can cover a number of points, and then this drone can actually travel, and then it can do surveillance, it can do recce, or it can also deliver load wherever one wants. So this basically uses satellite link for GPS location. It is basically intermittent RF link. Whenever it reaches to a place, then it basically tries to confirm it has reached there. And this can be this basically enables operation of beyond visual line of sight. So somebody can give a location which is beyond visual line of sight. And then
Dr.
finally,
I have a question for you.
Yeah,
When you
yeah.
go beyond visual line of sight,
Yeah.
you are obviously dependent on your communication system. What is the range of RF communication you found that doesn't get interrupted in?
Yeah, so up to 2 kilometer we have tested. There have been, I mean, there's no issue there up to 2 kilometer. But yeah, of course, there are other communication devices which may also support beyond that. But when we are talking about semi-autonomous, we are saying it need not communicate always. I mean, I have given a point which is beyond visual range. So the platform will go there and then it will move to the next point, which may be close to me, or it may be further away from me. So that is the way it basically operates.
Okay.
Yeah. And then finally, in last maybe couple of years, we have been working on autonomous mode of operation where it is a sensor assisted navigation. So like I was telling, vision is one of the sensor. No RF transmission from base station. Normally, some landmark is basically uploaded while the mission is started. So for example, if I have carried out a recce and I have captured some images, I can give those images as a place where this platform should look into. So as the robot, I mean, this platform is moving, it basically tries to match the landmark which has been provided during the mission. So this is something which is for autonomous delivery of some load at some unknown location. The robot can be tasked to go to a distance of say 1 kilometer, and then while it has traveled naturally autonomously, it will deviate because of the onboard sensors which it is using. So then it can basically do correction of its location using the visual landmark that we provide. So that kind of correction is possible, and the good part here is that it is mostly for the short distances. This kind of operation is possible. So when you are looking at the drone technologies, we have to remember all these three modes of operation, and going forward, naturally people will add in the autonomous mode the newer thing. And the worst part is that because AI is mostly democratized and it is available in open source, so most of the technologies which are being developed around the world is available to everybody. I mean, not only as a scientist to us, but to anybody who wants to misuse it for any other purpose. Now coming to the technology trend, so one of the thing which we all talk about is the GPS denied operation. Particularly new technologies like quantum radars, which are in the horizon. So that will basically enable development of PNT systems, which can for this GPS denied environment, and this will actually render the GNSS jamming system obsolete. So that is one thing which we need to look into. The other thing is the cost factor. We all know that the drones have become really cheap. They have become very small in terms of size, weight, and power parameters, and they all, I mean, going forward, they will all be autonomous. So what it will enable is it will create a large swarm of drone as a very smart weapon system and very lethal weapon system. So that is one technology trend that we have to look into. The other is, of course, the 4G, 5G thing, which Sam also talked about, the LTE network control. So most of the current drones are being operated through RF control, but of course this 4G thing is also there. We have used for our ground platform, not for aerial. But then in future, a lot of these drones will be using this mobile network. And what it means is that the range of operation will become completely indefinite. So like today we talk about the limitation is because of the radio, and then in future that is going to be completely indefinite. Much harder to find where the operator is, and in many cases it not be even detectable also. The last point, which is again very important from the AI lab point of view, is that the onboard AI that is coming now and that is going to come. It may enable active avoidance of these weapon system which is being fired at it. So, for example, some of these drones may be trained to autonomously avoid incoming projectiles, and that is going to limit the effectiveness of the kinetic kill. So that point we all need to remember. I mean, that is going to be a challenge in very immediate near future.
I have a question for you.
Yes, sir.
Do you think the AI systems are also looking at countering the anti-jamming things? on the
Yes.
RF frequency and stuff?
Yes. So it will basically, so one is to find out that there are the jammers in the vicinity to avoid that. The other is to avoid the incoming projectiles. Both these things are possible. So on board, but of course the drones will be, of course, the bigger in size so that they can have that kind of payload.
Okay, another question from Mr. Narang. If you don't mind. Yes, Narang sir, quickly.
Yeah,
we're running out of time.
Mr. Arshad, just want to understand, if I understand correctly, you are from one of the DRDO labs.
Yes, sir.
Why is DRDO getting into drone domain when we have a robust small drone industry? What are the niche areas you are getting which our industry can't give?
Yeah, so we have been focusing more on autonomy and cognition part. We are not building drone. So we are using drone which is available in the market. That is one aspect to develop these technologies, cognition and autonomy. The other is the bigger drone platform that, of course, DRDO is developing. You all know there's a lab in Bangalore which develops the bigger drone platform. So there is no industry in India. So that is where the platform aspect, the autonomy aspect is for all drones. So we basically use commercial things.
Fair enough. Lovely. Go ahead, sir. Finish.
Thank you. Thank you.
Yeah. So now coming to some of the point, which is again in terms of monitoring and countermeasures. So everybody talked about detection. I mean the drone monitoring technologies. So for example, most of the traditional radar system, we all know that it will be able to detect objects, but it may not be able to discriminate between different objects. So it can say that there is a drone or there is a bird. It cannot discriminate. So we need techniques for classification or identification. So all current AI and machine learning based approaches, they are all can be trained to discriminate between different kind of drones. Then location and tracking, and then alerting mechanism. And in terms of response, Sam has talked about all these things: RF jammer, GPS spoofer, high power microwave devices, nets and guns, high energy lasers and birds of prey. So some of these things we all have heard today. So RF analyzer, we all know that there are advantages, disadvantages. Low cost, detect multiple drones. We can triangulate drone and controller position, but it does not always locate and track the drones. It cannot detect autonomous drones. So like layered approach Sam had talked about, that is very, very important. That for different problems we try to put these solutions. Acoustic sensors are always there. So I mean, so some of these are passive, some of these are active. Once you detect a drone, you need to find out that what is there on the drone. So for that we need optical sensors. So there are various options. Again, this is a passive thing. So it provides.
Dr.
Saab,
sorry to interrupt.
Yes.
We're running out of time.
Yes. I'll just
there are a couple of
through this
questions
because
for you which I want you to answer.
Yeah. So
I want to apologize to our speakers and to General Panu for the delay. So my apologies.
Yes. So I'll just rush through these things. So for monitoring, we have multiple options. Some of them are more suitable. So now everybody talked about this radar system, particularly the micro radar system, which can discriminate moving parts in a system, and that is how it is able to distinguish drone with the bird. Drone response system, again, Sam has talked about RF jammer, GPS spoofer, high power microwave devices. So for example, if you're talking about swarm of drone, the laser may not be very helpful. We need this kind of directed energy weapon system, which is high power microwave devices. So just to conclude, the anti-drone system. So this is one of the system which we all know that DRDO has developed. So depending upon the use case, there are various options which is available for monitoring and responsive technologies. We can all integrate together to create anti-drone system. Command and control is, of course, very essential component there, which should be basically able to collect data from various sensors, process them, displace them, and then in a user-friendly way. So this is what I wanted to communicate.
Thank you. There were a couple of questions. Sam, you want to react to this autonomous drone story quickly before we close down the session?
Yes, autonomous drones is something interesting. But first question is, why someone fire autonomous drone? Means it's like a kamikaze. So when he's kamikaze, you break all the rules. Yeah. So this will be the highest threat that we need to address. So I think Dr. Jamal have presented the case. This will be one of the challenges. But radar should be able to pick it up, and you probably need a hard kill solutions. So this was something need to look in R&D. It's a roadmap. Yeah.
Sounds good. All right, team. Thank you so much, everyone. It's been very, very interesting. It's been so interesting that I've delayed our next session. My sincere apologies to General Panu. General Panu, please forgive us. It was so fascinating listening to all the speakers. And thank you for curating this event. I'm signing off now, and over to you, General Panu, for the next session. Thank you.